Recently I bought a vector network analyzer. It's a great tool to inspect PCB traces and cables. And probably you know it has a transform option to transform the frequency domain signals into a time domain signal. And this will give you a reading of the impedance similar what you expect from an TDR measurement. And here I have a sample PCB with different transmission lines. And now we can measure the impedance, and let's start with a good one. So if I connect it to the instrument, you can see on the beginning the impedance of the cable, which is close to 50 ohm, and then the trace has also an impedance of 50 ohm, and you can see that discontinuity they are caused by the SMA connector. And now I have a second PCB which has an identical structure. And now let's measure this. But as you can see here, there's a massive discontinuity in the impedance right in the center of the trace. So let's have a closer look on that trace. But if you look from the front, there's nothing suspicious. But if I flip the PCB around, you can see there's a cut in the ground plane, and this causes the effect of the changed impedance. And now I can show how to repair that. So I have a metal blade, and if I put it on the edge of this cut, it already improves the impedance. But if I place it right under the trace, the discontinuity fully disappears. And this shows that the RF current prefers to travel the path of the least inductance directly underneath the trace along the ground plane. And I think this is a nice example why you should not have any cuts in the reference plane.